Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at solving quadratic equations, but this time dealing specifically with fractions and negative exponents. So let's go ahead and get started. So we've talked about solving quadratic equations before using quadratic form, and that involves using a technique called U substitution. Again, basically what's happened is that when we're dealing with quadratic equation in which the form does not follow what we expect. So traditionally we expect it to have something along the lines of like, x squared plus, 3x plus c. So notice how we have a second degree term here and a first degree term here. But what's happened is that in this video we're dealing with examples that don't follow this format. And so we have to find ways to address that, and one of the tools that we use is called U substitution. So let me go ahead and show you our first example for this particular video. We're going to have two examples. So our first example is going to be x to the 2/3 power minus 5x to the 1/3 power minus 14, and of course it equals 0 because it's a quadratic equation. Now our problem here is that we have this weird 2/3 power here and we have this weird 1/3 power here. They're not the same. So it's going to be difficult. Well, they're never the same, but they don't follow what we expect. We cannot plug this into like a quadratic equation as an example because it doesn't have that second power thing going on here. It has a 2/3 power and a 1/3 power. So to address that, we first need to find a way in which this 2/3 and this 1/3 are the same. When they become the same, we can then use U substitution. What's going to make more sense when you see it rather than when I talk about it theoretically. So here's what we are going to do. Another way to write x to the 2/3 power is as follows, and this is just from being familiar with exponent properties. I can write it as follows. I can say x to the 1/3 like so, and then raise that to the second power. This is the same thing, and you must be familiar with the properties of exponents to appreciate what I'm talking about right now. And then of course then I have minus 5x to the 1/3 still minus 14 equals 0. Now here is the benefit that we have from doing this. We have a 1/3 here and we have the 1/3 here. So what we can do now is we can do the following. We can say u equals x to the 1/3 power. And so what we do is this. Wherever we see an x to the 1/3, we replace it with a u. That's what we're going to do. And so now we end up with the following. Instead of having x to the 1/3 raised to the second power, we're going to have this. We're going to have u squared, because that's what's inside here, minus 5u, because that's what this is right here, minus 14 equals 0. Now we have all the tools we need to solve this using whatever we want for factoring or the quadratic equation, whatever. Now what we need to figure out now, and I'm assuming that you're already familiar with basic how to solve quadratic equations, is we need to find something that when we multiply them together we get minus 14, and when we add them together we get negative 5. And so just looking at this real quick and being comfortable with numbers, I can tell you that one acceptable answer is going to be u minus 7 and then u plus 2, because what's going to happen is this: 7 times 2 equals negative 14, because that's a minus 7, and then minus 7 plus 2 is going to be minus 5, and we got the u there, and we got the u squared. So that's going to be our answer right there. And so we know now, and remember this all has to equal 0 by the way, we know u can equal either 7 or negative 2. That's what we know. So we're almost done. We're very, 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 very close to being finished. So I'm going to try to squeeze this onto one slide here by using this little area right here. So this is what we're going to do next. We're not done. We know that u equals that, so we just plug these in. So here's what happens. We're going to use this. We know what u is. U is 7 or negative 2. So now this is what I have. X to the x to the 1/3 equals 7, or it equals 2. So what do I do now? Well, to deal with this, I have to raise everything to the 3rd power. So I take x to the 1/3, I raise to the 3rd power. I take 7, I raise him to the 3rd power, and I take 2, I raise him to the 3rd power. And so what I end up with now is I end up with x equals 7 times 7 times 7, that's a big number, 343 Oh, I need to be careful because this is a negative. Whew, I need to be careful. Or x can equal negative 8. So let me explain what I did here. I took x to the 1/3 and I raised it to the third power, because by doing that I eat the fraction here. And so whatever I do on the left hand side of the equal sign, I do on the right hand side. So I have 7 to the third power, that becomes 343. And then for my second equation, and I kind of save space, maybe I'm cheating a little bit, I also raised the negative 2 to the third power. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So in other words, this particular equation, it crosses the x-axis at x equals 343, and it also crosses the x-axis at x equals negative 8. And you can check that for yourself. And so this is how we deal with this when we're dealing with fractions. All right. So this time we're going to deal with a negative exponent. Let's see how we can address that. So we have 8x to the negative 2 minus 10x to the negative 1 plus 3 equals 0. And so again, we have the same problem. These negative 2 and this negative 1, it does not follow the proper format for like the quadratic equation. And so we got to find a way to work around that. So if I can get these to be the same in some sort of way, I'll be okay. So here's what we're going to do. Taking our knowledge of exponents, we can do the following. Let me make that a little bit smaller. We can do 8. And then inside here we got x to the negative 1 raised to the second power, because negative 1 times 2 is going to be negative 2. That's all we're doing here. Minus 10x to the negative 1 plus 3 equals 0. All right, so now we can do our u substitution. And so this time our u is going to equal x to the negative 1, because that is what these two terms have in common now, is that x to the negative 1. Therefore, following this idea, we get the following. We get 8 u squared, because x to the negative 1 is u, and then just raise it to the second power, minus 10u plus 3 equals 0. Now, this one is tricky. There's always more than one way to solve this. We could do factoring, we could do the quadratic equation, whatever you want. Quadratic formula, excuse me. But what we're going to do is we're going to factor this. And so if we factor this, we get the following. We get 4u minus 3, 2u minus 1 equals 0. That's what we get. Now we have to play with this a little bit to try to get the correct answer. And so how did I get this? It's just factoring. I factored the 8, and then also I made that, two terms add up. You can check this if you want to verify it. And so now I have 4u minus 3 equals 0, and then I have 2u minus 1 equals 0. So how do I deal with this? Plus 3 over here, and then I know with 4u equals 3, so I know that u is going to equal 4 over 3, because I have to divide this by 4. Oh, excuse me, 3 over 4, sorry. Because I divide by 4, that's what I'm left with. So dealing with this guy right here, 2u, so plus 2, and then I'm left with, what am I doing? Excuse me, plus 1. 2u equals 1, divide by 2. So u in both these situations, u equals 3 over 4, and the other answer is 1 over 2. Now, we're very, very close. All we got to do now is we substitute 3 over 4 for u, substitute 1 over 2 for u, and then we solve for x to the negative 1. So let me go ahead and set up my space here, like so. And let me wrap up my solving here. So now what we have is this. We have 3 over 4 to the negative 1, and we also have 1 over 2 to the negative 1. Now this one's easy, because when you raise a fraction to the negative 1, you just find the reciprocal. So in other words, x equals 4 over 3, or x equals 2. That's it. We're done. And again, you can check this if you want by graphing the equation as well. And you will see that it crosses the x-axis at 4 over 3, which is about 1.33, and also at 2. So let me go back and explain what we talked about in this video, and then we will conclude it. So in this video, we talked about how to deal with quadratic equations, putting them in quadratic form when we're trying to deal with exponents and also fractions. So our first example focused specifically on fractions. And so you have to find a way to deal with this fraction right here, in the exponent, I guess the whole video is about exponents, but this one's about a fractional exponent, if you will. And you have to find a way to deal with that by your knowledge of exponent properties. And so once you make sure that the first two terms have the same fractional exponent, you could then do U substitution to find the appropriate answer. And the steps are labeled here for you. In the second example, this time we had a negative exponent. So maybe the video should be entitled Fractions and Negative Exponents. I don't know. And so again, using your knowledge of exponent properties, you have to do that before you do the appropriate substitution. From there, it's just a matter of factoring, or if you want, we could have used the quadratic equation right here and then finding the two answers. So I hope this video was useful for you and that the concepts that we talked about here made sense and you had an idea of what was going on. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.